Assalamu alaikum. Hello everybody. I'm Khalid Al-Amin Awad, teaching assistant of anatomy. In this session, we'll talk about the development of the cardiovascular system. Okay, so this is the title of our session, the development of the cardiovascular system. In this session, we will divide this session into 3 parts to make it easier for you to study. So in this first part, we'll describe the processes and events in the normal development of the cardiovascular system. Then we will describe the events and fates related to the primitive heart tube. This is very important for students to describe and identify. And students, by the end of this session, should explain the congenital heart defects in relation to normal development. Okay. It is known that the heart, the first organ to develop and to function in the developing embryo. Why? Why we need the heart to develop and to function so early? And when we say early, the heart start to beat at the 22nd day. The explanation for this is that diffusion is not enough. We know that when the zygote is formed, travels in the fallopian tube, then in the heart, then start to implant. During all this period, the heart will get its oxygen, the embryo will get its oxygen and nutrients through diffusion. Okay, but when the embryo grows up, the tissues systems start to develop. This diffusion will not be enough to supply the developing embryo by oxygen and nutrients. So what we need the heart to pump the blood in a vascular system to all parts of the embryo. So the development of the heart starts very early, in the middle of the 3rd week, immediately after the process of fertilization and development of the 3 germ layers. And it starts from the splanchnic mesoderm. Look at this. The heart will start to develop from the splanchnic mesoderm. In the developing area, we call it the cardiogenic area. So we have cardiogenic area from which the heart will develop. The heart will develop at first cranial to what we call the oropharyngeal membrane. I will show you a diagram for this. This is we are looking for the embryo from above. Look at this. Here we have legs of blood here. This area here is called the cardiogenic area. We have splanchnic mesoderm, part of the mesoderm. We have here what we call the oropharyngeal membrane. Cranial to it here, we have this cardiogenic area. This oropharyngeal membrane will be the future mouth, and this is the cardiogenic area or the heart area. But this will be corrected by the process of folding of the embryo. The splanchnic mesoderm, which forms the primitive heart tube, will form the endocardium, the inner layer of the heart. But the heart is formed of 3 layers, myocardium and epicardium, in addition to the endocardium. So the other outer layers will also form from the surrounding splanchnic tutor. So the part which develops first is the endocardium. As we mentioned, the heart starts to beat very early, and this reflects its start to function at the 21st and or 22nd day. Let us explain what we meant by oropharyngeal here. If we, this is the ectoderm, the bread is mesoderm, and here we have endoderm. Here we have the yolk sac. This is the ectoderm. This part will be the developing brain. Here we have oropharyngeal membrane or future mouth, and if you look here, the splanchnic mesoderm here start to form a tube, small tube at this area, which is called cardiogenic area, and the white area you see here, this will be the future pericardium. But the red one here, this is the heart tube. If you look here, the heart is more cranial to the mouth and to the brain, but the embryo will fold. This part will fold, so the brain will assume cranial position, the mouth will be here, and with more folding, you can see that the heart tube comes here for the future heart. Here we have the mouth, and here we have the brain. In this case, the positions are corrected. So the first part of the heart which develops is called the primitive heart tube, and this form from this will form the endocardium. As we mentioned, this is the inner layer of the heart, including the epithelium and the lamina propria, or the layer of connective tissue. Everything starts to develop small, then it dilates. The more cells, more layers are developed, so the space will be smaller for the heart tube, so it start to make dilatations. As we mentioned, the heart tube, as it developed first, it will be like a tube, straight tube like this, and this tube, it will has two ends. If you look at this, and we can assume that the blood enters through here and it goes out through here. Okay, so this is a heart tube, and this heart tube will be in a pericardium. So the part which receives the blood will be called the venous end, and this is the arterial end. Okay, these parts are supposed to form the atria and the ventricles, but here it is just a tube. If you have this confined space and this tube is developing rapidly, as we mentioned that the cardiovascular system is rapidly developing, so what if you lay more cells and more layers? What happens? This tube will start to assume dilatation, to be accommodated into this space, the pericardium, the future pericardium. So what will happen for the tube which started as straight? Then it will make dilatations. These dilatations are given names according to what they will give in the future. We said that this is the venous end, and this end, venous end, is called sinus venosus. It will become dilated and it will form sinus venosus. So what is next to the venous end? It will be the primitive atria. And what is next to the primitive atria? The primitive ventricle. What is next to the primitive ventricle? Then we will have a dilatation which is called bulbus cordis, and then we have the arterial end which is called truncus arteriosus. Okay, so we have the arterial end which is truncus arteriosus, we have bulbus cordis, we have primitive ventricle, primitive atrium, and sinus venosus. We can start from here, from this sinus venosus, then we go, the blood will go to the atria, to the ventricle, to the bulbus cordis, and to the truncus arteriosus. So we have a tube with arterial end, venous end, with primitive atria and ventricle, and definitely this will give the outcome of the heart, which are the aorta and the pulmonary, as we will see in the next parts. Okay, I hope this is clear. This tube, why is it called primitive? Because this part will develop into atria and ventricle, so it is not an adult tube. The heart is not a tube, so this is why it is called primitive. So the heart will start as a tube, and this tube is primitive, and will give adult structures. Okay, this is the venous end, this part, and you can see that it is dilated. This is the primitive atria, primitive ventricle, and the bulbous cordis and the arterial end or truncus arteriosus. So as primitively, when the heart starts to beat, it will receive blood here, pass through this part and go to the organs again, and with more development, these parts will give atria, ventricle, and things like this. As we mentioned that this heart tube start as straight, then it start to make dilatation, but still it need to have space. So what will happen? This will loop. Okay, this heart tube will loop. It will make loop. This loop in the adult heart is important for positions of the atria and the ventricle, because if you look at the primitive heart tube which you have seen, the venous end was here and the atria was here, then the ventricle here. Okay, so what is abnormal about this? The atria is below the ventricle. So with more development, this venous end will loop up, and when it loops up, it will bring the atria here, and the ventricle will be at this side. Okay, and the outgoing arteries will be at this side. Okay, so let us look at this loop. The bulbous cordis and the ventricles move ventral and downward. The part which carries the ventricle and the bulbous cordis, the aorta and the pulmonary trunk, will move downward, and it become more anterior, while the atrium and sinus venosus move cranially and dorsally. They move up, as we have seen here, and they will become posterior, and this can be seen in the adult heart. The left atrium is the base or the posterior part of the heart, and it is superior to the ventricle. The two ventricles in the adult heart are anterior to the atria. Okay, they are anterior, and this what makes this change in position. This is done by this looping of the heart. And at the basic part, why we have a loop? Because there is rapid growth of the heart, and this will make changes in the position of the heart. Okay, you can see that the atria moved up. This is the ventricle became inferior, but they are ventral anterior, and you can see that the atria moved up, but they are dorsal. Here we have the truncus arteriosus from the ventricle, and you can see behind we have the sinus venosus, which will give the ventricle. Okay, if you look at this heart tube which we have mentioned, you can see that this heart tube we say that this is the atria and this is the ventricle as primitive parts. What is abnormal about these parts? They are common tubes. So in the adult heart, we have the left and right atrium, we have the left and right ventricle. Here, they are as one part. So in the next slides, we will talk about separation of these canals or chambers. Why? Because we need to separate this atrium, we need to separate this ventricle. We need to have right and left chambers. Okay, so it is important to talk about the development. But before we talk about separation of the atria and the ventricle, the atria and the ventricles themselves, they are not separated. The atria and the ventricle, they are here. You can see that they are a common. You can go from the atria to the ventricle. There is no valves, there is no separation. So the first thing which will form is we separate these two. The endocardium here will make cushions or protrusions, two protrusions. Okay, one anterior and one posterior. You can imagine this in the room where you are sitting. They are like curtains. If you push the curtain from the anterior wall to the dorsal wall, and with more growth, these two endocardial cushions will approach each other until they separate the two chambers. Remember, the atria became superior and the ventricle became inferior. What happens here? We have separated the two atrioventricular canals, although they are not separated, but here they are separated from each other. But there is no site for entry of blood. But then two openings will appear later to allow for passage of blood from the atria to the ventricle. Okay, so we have two endocardial cushions which separate, they approach each other, they fuse and meet in the middle to form the atrioventricular canal, where this will separate the atria on the right and ventricles on the left. We can see them here. This is the canal, the atria on this side, the ventricle here. Sorry, this is the atria and this is the ventricle. The blood is coming from the sinus venosus to the atria is trying to assume superior position. The ventricle are trying to assume inferior position. You can see here there is a start of something here. This is the beginning of the endocardial cushion. Still the blood can go. Still the blood can go here. But they will meet here, and when they will meet, they will close this canal, but the pressure of the blood from the atria will force these canals to open. You can see that now they are fused here, the two endocardial cushions, the atria on the right and the ventricle on your left hand. If we look at this coronal section, you can see that these are the endocardial cushions, but as we mentioned, we get two openings, two canals for passage of blood, and these two canals, they are, this is the right atrioventricular canal and this is the left atrioventricular canal. This later will be guarded by the tricuspid valve and this by the mitral valve. Look at the atria here, they are not separated yet, the ventricles are not separated yet, but there is a start of a septum. So next we go to the septation of the common atrium, and this start with a crescent-like septum, and this septum is called septum primum. Why is it called septum primum? Because it is the first septum, and if this is the first septum, it means we have another one. We will have septum secundum. uh, if this is the atria and here we have the ventricle, from the cranial part here a septum will start to form. If you make a coronal section, this will have a crescent like shape like this, and it will start to go down. Okay, so whenever it goes down, always there is this part of the crescent which will allow passage of the blood. I want you to remember something. In the septation or separation of the atria, we have two septa, but we have three openings. Another thing to remember, the blood in the embryonic atrium goes from the right to the left. Why? Because the pressure on the right side of the embryo is higher than the pressure on the left. Okay, so although we have the septum primum here, but still the blood can go from the right to the left. Okay, the direction of flow is this way. This is the left atrium. Okay, so all this part here is called foramen primum. Remember, this is the opening which allows the blood, and this opening is very big because the septum primum is small. But what happens if this septum primum grows down? The foramen primum will become smaller. What happens if it grows more? The foramen will become smaller, and the pressure on the right will rise, and this will make some openings here. Other openings will start to form at this side. So this is the first foramen. This is the second foramen. So what we will call this will be called foramen secundum. This is foramen secundum, and this is foramen primum, and this is septum primum. Remember, we haven't mentioned any of the other septum, which is not found yet. At the end, this septum will reach the area of the endocardial section. Remember, the ventricles are still lying down, so this septum will reach the endocardial cushions, which we have mentioned, and whenever this fuse here, this part of the foramen will become big. Again, this is foramen second. So let us see what we have mentioned. Let me remove this paintings. It descends from the roof downward in the direction of the endocardial cushions. You can see this is the septum primum, but all this white part is the foramen primum. This is the endocardial cushion. This is the direction of the ventricle. You can imagine the view here. So in this coronal section, this is the right atrium, this is the left atrium to be, and this is the start of the septum primum, which you are seeing here as crescent, and all this is foramen primum. If it descends down and this foramen primum becomes smaller, other small foramina will start here, and this will be the beginning of foramen secundum, and still we have flow of blood from right to the left. So this septum primum separates the left and right. It has an opening downward, which is foramen primum, the lower part. This foramen primum disappears because the septum primum fused with the endocardial cushion. But while it is disappearing, another foramen will appear, and this foramen secundum. So just to remind you, in the septum rhymen, we have two openings. In the septum rhymen, we have two openings. Foramen primum lower down, foramen secundum upper. Okay, we have never mentioned septum secundum yet. The foramina allow passage of blood from the right to the left, as we have mentioned that the pressure in the right is higher than the left, and this will not be changed unless we have birth or the mother gave birth to the baby. At that time, the pressure will change. Okay, septum secundum then will descend again from the roof to the right of the septum primum. Let me remind you what we have mentioned here. This is the atrium. We have septum primum, but we have an opening in this septum. It is fused down, but it has an opening here, which is foramen secundum. We had foramen primum, but it is now, it disappeared now because this is fused here. We will start to have another septum which will descend down. This is septum secundum. Look here, the blood is flowing in this direction. Okay. Whenever this septum is descending down, the foramen will look like being obliterated. Okay, but actually, what happens? The blood coming from the inferior vena cava will push this septum, and what happens? This septum will open like this, and the blood will go through this two foramen. Okay, so this is septum secundum, and this is septum primum. We have the blood, as I mentioned, it comes through this part. What happens if the blood tries to go from the left to the right? It will not pass, because if you push this septum here, it will fuse with this septum and it will close this part. So this opening, this new opening created here, this is called foramen ovale. This is called foramen ovale. So the passage between the lower part of the septum secundum and the foramen secundum is foramen ovale. So the foramen ovale is not like foramen primum or foramen secundum. No, it is a complex opening. The blood should pass below the lower part of the septum secundum. Septum secundum, this is something to mention, doesn't reach the endocardial cushion like the septum primum, because if it reaches this part, it will close the blood completely from the right to the left, and we don't need this to happen. So there will be a passage between the lower part of the septum secundum and the foramen secundum, which we mentioned in the septum primum. This is foramen ovale. Okay, this foramen ovale will be there until we get birth. At that time, the pressure in the left will rise and in the right will decrease, and this foramen will be physiologically closed. Remember, physiologically closed at first, and these two leaves will remain attached to each other physiologically by the high pressure, but after a month or so, anatomically these two leaflets will attach to each other, and they will form closure of this foramen ovale, and it will be the fossa ovalis. This will be fossa ovalis. Okay, so this is a very important clinical part, which is the formation of the foramen ovale. Remember, sometimes we can get patent foramen oval. Okay, the cranial part of the septum primum disappear. All this part will disappear to make easier passage of blood. You can see here we have two septa, but it is more clear on the coronal section here. This is the remaining part of the septum primum. We have septum secundum on its right here. It is starting to descend. Foramen ovale is very big here, but when it goes down, this will the blood should push this door. This door is the remaining part of the septum primum. You can look at this. This is the blood flowing in the foramen ovale. When we'll talk about the fetal circulation, I will give you more detail about this blue arrow. Why this is red and why this is blue. Okay. So this foramen ovale allows the flow of the blood from the right to the left atrium. And as we mentioned, fossa ovalis is the adult remnant of the foramen ovale after its closure. If you examine any adult heart, you will see the fossa ovalis. Fossa ovalis, it has no importance, but it tells you the historical importance or presence of foramen ovale. So, to summarize this first part, we talked about the primitive heart tube and its dilatations. This heart tube starts as straight, it gets dilatations at its fold. These dilatations, we give them name as the future structures from them: the primitive atria, the primitive ventricle, the venous end, which is sinus venosus, the arterial end, which is bulbus cordis, and truncus arteriosus. We started to separate the atria with two septa, and in these two septa we have three foramen. The two septa, the first one is septum primum, first, septum secundum. The three openings are foramen primum, foramen secundum, and foramen ovale. Remember, foramen ovale is a complex part formed by the lower end of the septum secundum and the foramen secundum. Okay. So what we have now, we have separated the atria from the ventricle by the endocardial cushions. We have separated the two atria from each other. Still, we are having the blood flowing from the right to the left, and part of it is going to the right ventricle. This is a diagram for the dilatations of the primitive heart tube. As the heart develops, this primitive heart tube starts to change into adult heart. Okay, thank you. So this is the first part of this, which is the primitive heart tube and the atrium.